Hi, good evening, team. So today we are going to look at the concept of application load balancer. So what exactly is load balancer? Yesterday we had a look at auto scaling, which was scaling up and down of the instances as per the load of our application. Now we need to balance the load as well. For example, in our application, we have different instances, different servers and different availability zones. We don't want all the traffic go into just one availability zone. For explanation, if a customer is accessing this over internet to our servers, then we need to put an automatic application load balancer, which is internet facing, and it will distribute the load between these two applications. This is the internet facing load balancer. After it reaches that, mostly it's the web servers. This one is network load balancer, which we'll look at in our next lab. This is the internal load balancer, and which goes to our database servers. So we are going to look at it practically. So the way to deal with that is we need to first of all deploy our application. So what I did, I have created three different instances, assuming that this is my application, in three different availability zones. So that if one availability zone, if it's not available, the user can go to other availability zones. It is an internet facing one. That's why it has a public IPv4 address. And I have chosen a keypad. This is a Windows 2022 server I'm using. And after this is completed, I'm not using the auto scaling in this one, just the load balancer. I have made so for availability zone A, I'm using server 1, B2, C3. Okay, after I created these instances, I need to, so one other thing. I created this instance using the launch template. Let me show you so that I don't have to do 200 clicks after I did one. I just created one and then I use a launch template to launch the other two. Then after each of them were launched, okay, I will reconnect it. Let me see. Maybe because it was there for some time. Okay, this one is still connected. I made it the last. Okay, that one is disconnected as well. So what I did, I enabled the web server over there so that I can reach all three of them. For example, if our application is reached by one, if it cannot reach through that, it can load balance to the other one. Now, after creating the instances using the launch template, I need to go into the load balancer and it will take care of the target groups automatically. I will explain what target groups are. So application load balancer, that's what I named it as. Just giving a brief ahead. I will show you each step how to do that. DNS name is the name which resolves into the public IP of the servers. This is the main tunnel through which we'll be going into each server to access our applications. I'm using the default VPC. Of course, different availability zones. It's an application type load balancer. Now, um, first of all, let me show you what it looks like so it shows the VPC again with three different zones, AZ 1, 2, 3, and it shows internet facing. Like I mentioned, it's an application one. IPv4, I didn't take dual stack right over here. Listeners. So listeners are the ones like it they listeners are responsible for listening to which port number the user wants to go to. Here it supports HTTP port number 80, and there from it routes the traffic to the to the target groups. Target group is a group of targets or the instances which contains our application. In the network map, I will show you how to create those. One moment. So in VPC, default VPC, in the network mapping, availability zone, it just shows the same thing once again. Resource map. So the listener is listening, forwarding it to the traffic group. The three healthy instances. Healthy means it performs the health check. I will show that as well. So that's how it reaches our destination, this common security group for it. We can use different integrations, but that's not my criteria right now. At, okay, let me show you how did that work. I'm going to create a new load balancer. So application load balancer, it shows the description with HTTP, HTTPS. I didn't use HTTPS because it needs a certificate. Okay, so let's create this. Let me say, okay, application load balancer 2, internet facing. That's what I'm going to take it, IPv4. This is the default VPC. I'm going to load balance it on all of the three availability zones. I have created a security group, this one. We can choose more than one security groups as well. That's not an issue. I can choose HTTPS or HTTP. So now this is where we can create the target group. Now let me show you the diagram. Did I open it or I closed it? Anyways, when the listener from the load balancer, it listens to where the users of our application want to go to. So let me open this for you. These are different kinds of target groups. Target groups are the group of targets where they are trying to reach us. IP addresses, remember this should be a private one, not a public one. Lambda function would be serverless. Over here, I'm looking at instances to keep it simple. Load balancing to instances within a specific VPC. Okay, so target group, I can give it a name HTTP IPv4, and this is the most important part. For example, if I assign a target to the load balancer, it's not going to trust us and it's going to do a health check. Health check means it is going to ping that target to make sure it exists and it's reliable. So it ping HTTP port, the number of consecutive health checks success required before considering an unhealthy target healthy. So we can the number of health check success. So successful ping commands. We can choose up to 10, the more the better, although it takes more time. Unhealthy, if two times it doesn't ping or ping fails, it will consider it unhealthy. This is the amount of time which we gave to response. If it doesn't respond in that time, we consider it failed. The amount of time between two pings is this success code. This is the normal 200 code for the HTTP, which it will return if it pings successfully. That's how it checks each and every target, which comes under the target group. So we can create a target group from here. If I choose this one, it will automatically switch it. We can give it a tag listener. Load balancer tags, we can give it a name. This is for protection access control list if we want additional. This is for giving it a couple of IPs for more performance and security purposes. So this is the internet. This shows a summary what I will do to configure it. Internet facing security group. I will choose how it's going to work. I'm going to choose three availability zones to load balance on this port and the protocol. Server side task. I didn't do much. I didn't do much about this one. So it's just the name and the protocol. So anyways, so that's how we create the load balancer for the application. I'm not going to create another one. I already created this one. Now I'm able to log into the Windows and to access the servers. I will show you. This is the DNS name. For example, yahoo.com. If I made that, or facebook.com, if I'm the owner of that, just the DNS name is needed. It will automatically convert it into the IP. So I copy the DNS name. I will just close this and copy it over here. So availability zone B1, 3 availability. So it is load balancing among those three servers where our application are. Let me make a change. Let me just reboot a couple of them. Then we will see. 1 and 2, let's try to reboot it. So that will cause an outage and only the 3 will be accessible. Only 3 is accessible. 1 and 2 are not accessible. So I didn't consider auto scaling in this part, increasing and decreasing of instances, but and only the load balancer in the so now looks like they came back. Yeah, 1, 3, 2. So in the next lab, I will be doing the network load balancer, and in some time in the future, I'm going to do auto scaling plus load balancer. Any questions, team? Just let me know.